it will log us in to show us the different test cases, and you group your tests in test suites. So today I've got this one here, the OWASP API security test suite that I've been building up to go through these examples. And so on the first one, we're talking about authentication, and one other, and this is an example of using the OAuth support within API Connect to access the API, and then validating that gets passed through, and that in this example API is a scenario where you've got a user profile, and the path to the profile is /profile example user, where example user is the username. So what we're validating is that the user that's done the authentication, the OAuth flow, is the user that's profile it belongs to. So when we run the test, I've got two of those. I don't know why I've got two of those. Anyway, I've got two calls to get the OAuth token, and then I'm using that token in the patch request to update the email address on the user profile. So what we're expecting to happen is this to, what have I done here? Yeah, sorry, I've got two OAuth calls, so I'm getting two tokens to start with. The first one is passing in, they're both the same. I've made a mistake here somewhere. The idea was that we've got two access tokens, one that's valid for this use case and one that's not. And the test is going to then try the patch with the valid token, and we've got this set to expect it to be successful. Then validate that the update has gone through and shows it as true. And then we've got a second patch that should have been using the invalid token, and validating that it gets a 403 response in the test. So I think what I was actually supposed to do is this first one, which was the token response error. Oh no, that's what it is. The second request is using a different username. So I've got the valid token, but I'm trying to update someone else's profile. So you see here that the first one was hitting example user, which is the user whose token I've got, and the second one is profile Ricky, which is my profile, and it shouldn't be allowed. So we're doing both a positive test case and a negative test case to validate that the checks are working as expected. Okay. So when we run those tests, hopefully we should see that the token request goes through fine. Then the first request to update the profile for example user has been successful, and we've got a 200. And we've done an assertion to validate that the profile has been updated, and that shows that as true, so that's good. And then the second request to try and update my profile with the token for example user has come back with a 403, so the test has passed, and that shows that's valid. So that's just a simple example of the sort of test you can use in the API testing to validate that a user can't update someone else's data. Obviously, depending on the system, this is very simple API, but if you could add more complicated assertions in there, and we've got a number of different options, which I'll come to some of these throughout the other examples, but you can add a number of different types of requests and different types of assertions to validate the data is doing what you expect, that the API has made an update or not made an update, and you can add those components into the test to extend it further. So if I jump over to the next example, which is broken user authentication. So this is where you've got an authentication system, but it's not working correctly, or it's been implemented incorrectly. One of the common areas that they found is where implementers of APIs have decided to create their own authentication system rather than building on standards. So the best practices here are to make use of existing authentication standards so that you're following something a well-known and well-understood path using things that can be validated and use existing libraries and tools to test and work with. But if you're building your own, you're out there on your own, you've got all of that to figure out for yourself and secure. So if this is broken, then you could end up with the ability to compromise the system or take over someone's account. In API Connect, we've got a number of options that you can use for authentication. We've got basic auth, integration with LDAP, authentication URLs where you can have API Connect pass the credentials to a back-end URL that then validates them. So that lets you integrate with any other system that's not covered by those standard approaches. We've got integration with using OAuth, either natively within API Connect or using a third-party OAuth provider, and JSON Web Tokens as well. Depending on which part of the scenario with broken authentication you're trying to mitigate, you could use something like MTLS on the transport flow to make sure it's further secured, or implement rate limits to make sure that people aren't able to brute force a password or similar credential. So in the example that I've got for this one, it's an example of someone implementing MFA for themselves. They've got two API calls. One of them, it would be a post request to send a token out, to say, send me a token to my mobile phone, and then it would trigger that SMS flow. And then the second request is the validation of that token coming back. So after the users put it into the interface, they have this 6-digit code to put in and validate. Now, for a modern computer to go through all the possible 6-digit codes would be fairly quick. So you don't want to be able to allow them to do all of that. So that's somewhere where we're going to make use of a rate limit to ensure that that only allows 2 attempts. So in this test, I've got an example of a rate limit. So I'm making use of the testing with invalid codes, and we're going to hit it multiple times. They should all start off by failing with forbidden because the code's invalid, and then once it hits the rate limit, it should then get a 429 to show that the call's been rate limited. So we're sending in a valid client ID to authenticate the application, but the code is invalid. So we're going through the first one. I've got a load of assertions just to check that the content is showing correctly as well, but I'm not doing those on every call because it should be the same. So then if we run this test, we should see, all being well, that the rate limit's working successfully. All the tests have passed. We're trying this with the code 111222. We got the 403 as expected to show that it was invalid and forbidden. And then we hit it again. We get a 403 again, so that's the second failed attempt because we want to let users make a mistake and put it in a second time. And then on the third attempt, we get the 429 that's been rate limited to stop them going any further with incorrect attempts. And if we get to that point in the user interface, we'd most likely pop up something that says you need to generate a new token or come back later, and have some other controls around the user flow to guide them as to what to do next. But the APIs would be protecting your automated attacks from getting into the system that way. So then the next one on the list, number 3, is excessive data exposure. It's quite common to build out an API based on a database model and build a user framework or something that will take what you've got in the database and expose it as an API and give you all of the objects without actually validating that that's all necessary in the API request. So it's quite easy to use the framework or implement something direct with the database and expose sensitive data through the APIs accidentally. So there's a number of ways that this can be protected against, depending on how your API is implemented. So for main areas that I would be looking at for this one would probably be making sure that the schemas are validated. that on request and response, so that your application at the back end isn't exposing values that aren't in the schema. And the same for the requests coming in, that there's no additional parameters being passed or allowed. You can also specifically, if you've got particularly sensitive data, we've got policies to do allow lists and block lists and redaction or removal of entries. So if you know that there's a particular field that's at risk of coming through, you can actually specify that one and say, we really don't want that one to come through, and put that in to remove from the responses or from any data that's logged. As I say on here with the configurable analytics as to what gets logged. And then we've also got further ways of doing this with custom policies and gateway script, which lets you write your own JavaScript code to validate and process data within the API flow. In the example I've got for this one, I'm going to be looking at using the the block list policy to remove a value. So I'll show you the API definition on this one. If it's going to load. Fun of a live demo. So this is a dummy backend, a dummy API that's not actually got a backend system behind it. It's all built with assembly flows and using some policies in API Connect to return sample data just for the purposes of a demo. So we've got a set of different flows for the different paths I'm going to be using, and in this case I've got this get image. I'll just make that a bit bigger actually. The get request for comments. So this is a example service that deals with images. Now they may be photos, they may be documents. It's just a generic upload an image and have comments about it. So in this case, we've got the processing of the comment, and the data that comes back from the back end is the ID of the comment, the image it relates to, the text of the comment, and the details of the author. So the idea is that the application developer has just joined those two data sources together to produce the data, and then you get the full author. You get the full author object from the database with their ID, name, and email address. And because the email address is considered sensitive personal information, we don't want that one to be exposed with every comment that they've posted relating to the images. So in this case, I'm going to use this redact policy to make sure that we're not including the author email in the flow, in the content of the API, in the body, and then removing it. So in this case, for the equivalent test, we're validating that data, that author email, doesn't exist in. So in the excessive data exposure test, we're using variables to reference the URL here. So we've got the full URL here with the image1 comment 3 and passing in the client ID. We're expecting to get a valid response back with a status code and the right content type. There's some data that we know must exist, and we know that the payload auth email must not exist because that's the one that we're particularly wanting to make sure we're protecting against here. So then if I run the test, that will come up with the assertions that have been made and go through, and we'll see here that we've got the exclamation mark here to show not exists for the payload author email. Now, if I were to go back and remove this redaction policy from the flow, so we're not removing the author email from the content, and then I should be able to republish this API. I've got it in a product for the image service. So then once I've got this published, I should be able to rerun the test and show that now, if the data is actually leaking through, that I get a failed test case. And that test case could be integrated in my CI/CD automation, so I deploy my API to API Connect, and as part of, in a test environment, run through the test cases automatically, and if it fails, stop that from being promoted any further. So now that API has been updated, let's run that test again. And this time we found an error, and here we can see that it's saying that this assertion failed because we're expecting no author email. So then we can have a look at the details in the report and load the source of the response and see here that we're getting that email address coming through that we're trying to prevent. So that test case would have prevented us leaking that email address in production. So if we move on to number 4, lack of resources and rate limiting. It's quite easy to end up building an API that doesn't impose restrictions. It's quick and easy to get your objects built out and define the API with just what the parameters are without thinking about the size or the limits to the fields. But if that's done without those limits, you can easily end up with an overflow of data hitting the back-end system, or denial of service attacks, and potentially some other issues with what data gets passed through if you're not controlling the input with authentication flaws and the handling of data and overflowing and causing a buffer overrun or something like that. So in this case, we would want to do some sort of attachment or content filtering, particularly in the case of the uploading files. In most APIs, you'd have a schema that you're building it around, so making sure that your API content is validated against that schema, and including things like field lengths and maximum payload size in that. Rate limits we touched on before, so as part of API Connect's plans, you can set the rate limits for different plans. There's a number of different limits that you can set depending on whether you can be strict for a particular field or whether you just need to make sure that the entire API definition doesn't go, the payload of the API goes over a particular value, or the complexity to reduce that. And DataBail's got built-in handling of some of the known issues with handling of external references. You can turn those off or restrict where they're handled as well. So in this one, I've got a few test cases that I've built. Again, with the image service example, let's just get the list of tests again. So first of all, I've got a test case that uses the image service with some valid parameters just as a positive test case, just to check that everything's working as expected. So in here, we're hitting the image service with a dummy image. Rather than actually uploading a full image in my test, I'm using a string that I know is 10 characters long. I've built out the validation of the schema to say it has to be less than 15 characters. So I know that this one should work. Obviously, if you're actually uploading files, it'd be a bit bigger than that. So then we check the usual things, so the content type and status. We're going to check that we're getting back the title, the width and the height, and the compression parameters used for the document that's been uploaded. And we're getting an ID back to show that that's been stored. So we run this test, and this one should be straightforward. Positive case goes through, everything passes as expected. So that's good. So then we can move on to the checks to check the validation is doing what we need it to. So the first one that I've got is exceeding a field limit. So in this case, I'm taking the same base API, but instead of having a 10-character string, I'm sending a 15-character string to make sure that it stops it from being sent on to the back-end system. And in this case, we expect to get a status code to indicate that that's not allowed with the 422. So again, let's run this test and see how that responds. So there we go, we've got the 422 back, as expected to show that that request was denied. And we see here we've got the post and something with having full screen. And then if I look at the source, we see here we've got this unprocessable entity and invalid string. The string maximum length must be at most 15. Now you can choose whether to include the detailed errors or not. Depends whether you want to give clues as to why it's been denied or just deny it. And that would depend on the requirements of the system. And then I've got a third example in this same API, and this time you may have noticed I've got the compression parameters in there. Some hacker may have seen that and thought, oh, you're getting compression parameters back when you post an image. Maybe I should try changing that and injecting some strings to maybe try running a command or pass them in, because the compression parameters look like something on a CLI type input. So where's this one gone? Oh no, that's in the next section. I'm moving on too far. That's part of section 6. So I'll come back to that one in a minute. So we've got 5 to go through first before we get to 6. So the fifth most common vulnerability is broken function level authorization. So ending up with overly complex access policies with hierarchies and ending up with an unclear separation between functions. You can easily end up with administrative functions that are mixed up with regular functions. One particular example would be handling users. So you'd often have a /users type model with all the details of the user, but list all users would be an administrative function, whereas getting a user or updating a user would be something that an individual user could do. So it's quite easy to end up with that hierarchy getting overly complex, and it's important to make sure that there's a suitable scoped authorization for those endpoints. So in API Connect, within the product, we've got role-based access control. So across the different objects within the API management system, we've got that fine-grained access from the cloud management, which is your entire deployment, the provider org, which is a provider deploys the APIs, and then the consumer org would represent the consumption from the app developer's perspective of those APIs. And then you can group the APIs by catalog and space, so you can actually get quite a fine-grained hierarchical access control for who needs to access what within the system. And then for handling the actual API invocation on the gateway, we support the use of OAuth with advanced fine-grained handling, which can either be done with some of the native OAuth provider, or you can offload that to an external system to integrate with your other platforms that you're using. So for this example, I have an example of using an invalid scope. So making sure that the API is checking the scope of the user, of the token, rather than just letting anyone through. So in this case, I'm doing the same test as I showed earlier of updating a profile. But in this case, I'm going to try it with just using a read scope, so I shouldn't have access to write to it. Obviously, you'd have more specific scopes if you're doing a real system, but this is a simplified example. So we're doing the token call, making sure we get a token back. That's all good. We expect that. And then when we make the call, we should get an error back because that token doesn't allow an update because it's only a read token. In this case, we're checking for a 401 to be returned, and we expect valid data with that in JSON, so we could go on and add assertions about the error. But for this case, I'm just checking the error code. So we've got a token that was successful. We can see that we've successfully requested that, and then if we look at that request for the token, we can see in there that we've got a token, maybe a bit small to read. Oh, don't know what I've done there. So in there we can see that we've got a token back from the OAuth endpoint, and it's got a scope of read. We can see then that we're trying that with the patch request, and we got a status back of 401, so that wasn't allowed, which is good because that's what we expected. If we were to update the test and change this token scope to use a write token or something, we could test it the other way, but I'm just going to stick with the negative test case here. Oh, wrong way. So then back to the one that I started to talk about before, mass assignment. So this is where, like, if we've got a data model that's tied from the database to what's being returned in the JSON, it's easy to end up with an API that allows more values to be set than you intend. So this is where I was going with the example with the compression parameters and allowing something to be set that then gets used for internal processing and is just stored in the database for that processing normally, but doesn't want to be either exposed or set through the client calls. This could either be something that someone attacking the API finds through guessing object properties or exploring how they're used. I mean, in the example I've got, you've explored the response from posting an image and then try doing a post with those properties set. So API Connect again has got the allow list and block list that we talked about before, and schema validation. A lot of the mitigations you can do here are similar, which is why I thought they were one and the same. But so then over here on this image service API that I'm using for this, I've got the implementation for posting an image set to initially pass the content that's being sent and then to validate the message against the schema, which I've defined as body param, so that then will deny any request that doesn't match that schema that's been defined as part of the API. So then if over on the test case I try sending some data that's not included in the schema for the body that you're posting, but is included in some of the responses, we can see that would get denied because it fails the schema validation. So here again, we've got a very similar body to we had before. We've just got some random strings in there. In this case, I'm just going to try putting some compression parameters with some ampersands, thinking that then I'd add some commands on the end if it actually executes it, and see how far I can get in the system. But in this case, the test is to check that it's actually blocked, so we're looking for the 422 to show that it failed the validation. So let's run that and see what we get. And again, this test shows that we're getting what we expected. And again, we can see the request that we made, check that it's still got those in the request. And in the source, we can see down here that we've got invalid object, maximum number of properties must be at most 2. In this case, I've got a schema that says it has 2 properties. You can say what the properties are. This, however you define your schema, is what it would validate against. And then that request would never get through the API management layer into your backend system. It would be blocked at the gateway. So the next most common one is the security misconfiguration. So commonly making use of insecure defaults or missing things in the configuration, using HTTP rather than HTTPS, allowing additional methods on the API that you don't intend to, and things like that. And there's a number of different ways that we can mitigate this. It's at the gateway, it's very easy to control what methods we allow, as you define the API definition to say only allow these methods that I want. We can use the global policies and user-defined policies to set something across all of the APIs to say this is how the APIs must work for this organization, so that you can ensure that API definitions in API Connect meet that expectation of your security level, which parameters are allowed, what policies you have to run for everything. Again, using schema validation and the API definitions, and making sure that you make use of the appropriate cause values. In this case, there's a number of different tests you could do. I haven't actually got a sample because just doing a test, it gets a bit repetitive. So we can do a call to an API that only supports GET and prove that sending a patch doesn't work. I've not done one because it just repeats the similar sort of thing. We send an API call, validate that we're getting the response back that we want, do a negative test, and validate that we get, in this case, if it's the API types, you'd get one error. Or if it's the trying an options call and get it for the cause, you can test that as well and make sure you've got the headers that you're expecting back. So then next one is injection flaws. So for example, adding SQL injection in parameters that you're expecting to get handled within the back end and pass straight through to the database. The example I used earlier of passing an extra command parameter onto a API parameter to try and get some code to run on the server. Again, this is something that we can do with checking the input types both on the gateway through the schema validation and in the application itself. We've got XML and JSON threat protection built into the Data Power Gateway, and some custom options that you can do for handling filtering of SQL and cross-site scripting through custom policies on the gateway and making use of the functions that are available there. So there's lots of different things you can do, and it all really depends on what your back-end system is that you choose which set of things you'd use here. I mean, the example I did earlier is one thing for command execution, and those sort of things can be tested in a similar way. So the next one, improper assets management. It's easy to expose more and more endpoints as APIs as you can just build out functions. It's very often that we get more content exposed through APIs and more functions and methods than you'd have in a traditional application because you're building them out for the future rather than necessarily just what's needed now. So it's important to make sure that all of that is managed and controlled, and that's really where an API management platform comes in, such as API Connect, to provide that lifecycle management for the APIs, so that you've got a central place to document and define all of the API definition, and we've got lifecycle management built in to cover things like approvals. So you could build an API in development, and then when you want to promote it to the QA environment, that goes through a set of tests and is approved. You can then approve who subscribes and then manage all that with different roles throughout the system for the whole life cycle of the APIs and the products. And then the last one we've got is insufficient logging and monitoring. So making sure that you're logging and monitoring what's going on with your APIs and handling anything that comes up is also key. Making sure that any attacks get noticed rather than just go under the radar. And key to this in API Connect is making use of things like the built-in API analytics. So you can use that to identify use of the API, make sure that you're seeing the expected levels of usage, monitoring the levels per application. So it gives us really good structured data as to about how the APIs are being used. So in this, I've got an example for testing where we actually test calling an API and make sure that the details of that API call end up in the analytics subsystem. So there are things that you can set in an API definition to not log data to analytics. So this is really a misconfiguration test, but also a test of the platform to make sure things are working as you expect. So in this one, rather than using an API that I've built in API Connect, I'm actually calling API Connect's API itself. So this is assuming I've made the API call separately, and then we call the API endpoint for the platform API on the API Connect system to request a token using our API key, and then validate that we get the token back. Once we've got that token, we use that to to make a call to the analytics subsystem API on /analytics, name of the analytics subsystem, because you could have multiple ones, which provider org we're using, which catalog, and to get the list of events. In this case, I'm looking for a particular API, and I'm looking for it being called in the last 24 hours. For demo purposes, if I was doing a test, I'd probably do last 15 minutes because I'd be calling it in the same test case and making sure that the data's come through. So then, once I've got that, I'm going through checking that I've got more than 0. I've got some events showing, so more than 0 there. And for each event, I'm making sure that we've got the log policy set to activity, which is the option as to how much data we're logging. Within analytics, you can either log activity and headers, or the full payload for request and response. In this case, we want to make sure we're just logging activity because we don't want to log sensitive data accidentally. So I can then run this test against the API Connect Analytics API and see that we're going through. We made the call. We've got more than 0 events, and in this case, we have got 3 APIs, and we're going through the results from each one.
Question?
Yeah.
How do you ensure that you're not logging PII data, for instance?
Yeah.
That's a common problem.
Yeah. So the redaction policies would be something you can put in your API flow to take it out or replace it with asterisks. And then you could build a test like this to look for those specific fields to validate that they're not ending up there.
You've got redaction.
Yeah, so you've got redaction in the, have I got an example?
I missed the beginning of your talk.
Yeah, so we've got this redaction policy here, which on one of the others, I'd used it on the example for the payload that's coming back from the back end, but you can also use the same for the data that goes to analytics to make sure that you're not logging things that you don't want to be. So that's the end of the 10 items. I've got a link here for the free trial for 30-day trial of API Connect on AWS. So it's also linked to from the QR code on those. This one just takes you straight to the sign-up form. So on that, if there's any other questions. If not, thank you very much, and I'll be around all day if anyone wants to catch me to discuss further.